Hello and welcome back to another video. Today we're going to be talking about Trigonometry 4, which is going to be on the subject of identities. So firstly, as always, topic 1 will be our review. Now in the last video, what we did is we realized that if we take two triangles like so, where that is a right angle and that is a right angle, this length is 1, and we can refer to these angles as theta 1 and theta 2, we were able to come up with the identities of cosine theta 1 plus theta 2 is equal to the cosine of theta 1 cosine of theta 2 minus the sine of 1 theta sine of theta 1 sine of theta 2, and that the sine of theta 1 plus theta 2 was equal to the sine of theta 1 cosine of theta 2 plus the cosine of theta 1 sine of theta 2. And I'm going to recap quickly how we got that. What we can do is we can draw a line from here down. We can make a construction. As it so happens, this angle is also equal to theta 2. Using our triangle information, this long side is the cosine of theta 1, this one is the sine of theta 1, and then down here, this side, this is a little weird, we need to draw another construction across here, and this little length right here is equal to the sine of theta 1 times the sine of theta 2, which means so is this side down here. We know that the entire height of this is the sine of theta 1 plus theta 2. I'm not, kind of looks like I'm drawing to this line, but I mean this line right here. And because of that, this side down here is the cosine of theta 1 plus theta 2. And if we add the entire length, like so, the entire length of this side equals the cosine of theta 1 cosine of theta 2. And lastly, this side right here is equal to the cosine of theta 1 sine of theta 2. Now, I believe we could start putting the pieces together. So the cosine of theta 1 plus theta 2 is this entire side like down here. And we've broken that up into two parts. The cosine, this is this length here. We've broken that up into two parts. The entire length, which is the cosine of theta 1 cosine of theta 2, and this short length, the sine of theta 1 sine of theta 2. So by getting this, we just subtract this from this. Thus, cosine of theta 1 plus theta 2 equals this length minus this length. Now, sorry, my camera froze there for a second. Our other side length, sine of theta 1 theta 2, is this length right here. And we see that that is the sum of this length, sine of theta plus cosine, sine of theta 1 plus cosine theta 2, which we find by this triangle right here, and cosine of theta 1 sine of theta 2, which we could find from this triangle right here. And if we add those, that's where we get this from. Moving on to topic 2, we're going to look at some examples of general identities. So let me write that. Topic 2, general identities. Now the definition of an identity is an equality between two expressions. So for example, we could have a plus b squared being equal to a squared plus ab plus b squared. The identity is the swapping between them. If we see this, we can replace it with this, and vice versa. Another few examples is if we have the sequence 1/2 plus 1/4 plus 1/8 plus 1/16 ... being equal to 1, because eventually, if this goes on for infinity, it will eventually equal 1. Another example we can do, and this applies into our application, is a cubed minus b cubed, which is pretty similar to this in the form that it takes the form of a minus b, a squared plus ab plus b squared. Like that. Now this ties into our application, because as such, if we replace a with x and b with 1, we get x cubed minus 1 is equal to x minus 1, x squared plus x plus 1. Now, if we have that in an integral, say we have the integral of 1 over x cubed minus 1 dx, we can split it up. So we have 1 over x minus 1, x squared plus x plus 1 dx. And then we can do a decomposition, which I'm not going to show the work here to save time, but this results in the integral of 1/3 x minus over x minus 1 minus 1/3 x plus 2/3 over x squared plus x plus 1 dx. And then we can split this and continue onward. Our final example is the Fibonacci sequence. Is a sequence, Fibonacci sequence, if you don't know, is a sequence where the two numbers adding together is the next number of the sequence. So 1 add to 2, 1 and 2 add to 3, 2 and 3 add to 5, vice versa. We keep going. Now, if we label each one of these numbers in the sequence with A1, A2, A3, A4, etc., we can find any given value of the sequence, noted as an, by finding the value of an minus 1 plus an minus 2. So say if we were looking to find a4, which is 5, we would take an minus 1, 3, an minus 2, 2, which is 5. Moving on now to topic 3, we're going to look at some trigonometric identities. So those were more geometry oriented. Now we're going into trigonometric identities. Let me write that. 3 trigonometric identities. Now, again, as a reminder, if we draw a unit circle, or again, the radius is 1, and we draw a triangle like so, where this arc length is theta, this side length here is the sine of theta, and this section right here is the cosine of theta, dropping down from where the radius hits the top of the circle. Now, from the Pythagorean theorem, a squared plus b squared equals c squared, we can note that the cosine squared of theta plus the sine squared of theta is equal to 1 squared, which is just 1. Now, this implies that if we move some things around, that the cosine squared of theta is equal to 1 minus the sine squared of theta, and that the sine squared of theta is equal to 1 minus the cosine squared of theta. Now, we also know that the cosine of minus theta is equal to just the cosine of theta, which is known as an even function, meaning that even if the variable is negative, it still comes out positive. And odd function, say the sine of negative theta would come out as negative sine of theta. Now, knowing our previous information, and I'm going to write them out again, that cosine of theta 1 plus theta 2 equal to cosine of theta 1 cos theta 2 minus sine theta 1 sine theta 2, and that the sine of theta 1 plus theta 2 is equal to sine of theta 1 cos theta 2 minus cos theta 1 sine of theta 2. Now, we can denote this, and this is going to go a little long, so I might need a second sheet of paper. Or actually, you know what? I'll just do them side by side. So, we can say that the cosine of 2 theta is equal to the cosine of theta plus theta. We know that from just general knowledge. Now, we can replace cos theta plus theta. We can replace this with cosine of theta cosine of theta minus sine of theta, and So, in other words, we reach the conclusion that the cosine squared of theta minus the sine squared of theta. That's basically what this means. I don't know why I said conclusion. So now we're going to work this out side by side, two cases, each one for the cosine and one for the sine. I think I have enough room. Yeah, okay. So we're going to do the cosine first. So we see that the cosine of 2 theta is equal to the cosine squared of theta minus sine squared of theta by our earlier calculations of like 5 seconds ago. And my paper's being moved. There we go. So we can note by some of our earlier identities that the cosine of 2 theta is equal to the cosine squared of theta minus 1 minus the cosine squared of theta. We substitute the negatives, so we have cosine of 2 theta equals cosine squared of theta minus 1 plus the cosine squared of theta, like so. There's no parentheses there, me. This means that the cosine of 2 theta is equal to the cosine of theta squared, 2 cosine of theta squared minus 1. We're going to flip the equation, so now we have 1 plus the cosine of 2 theta is equal to 2 cosine squared of theta. I'm sorry, this is the step where we flip. We just moved the cosine. My bad. Now we flip. We have 2 cosine squared of theta equals 1 plus cosine 2 theta. You would have to add negatives here, but because it's the cosine, it doesn't matter. Well, it does matter, but it cancels out. And we are left, then if we divide by 2, we're left with the conclusion that the cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2. And that is our identity for the cosine squared of theta. Now we're going to do the sine squared. So again, we start the same way. Cosine of 2 theta equals cosine squared of theta minus sine squared of theta. But then instead of substituting the sine, we're going to do the cosine, leaving us with only sines. So it'll mean the cosine of 2 theta is equal to 1 minus the sine squared of theta minus the sine squared of theta. We combine the sine squared of theta, so then we have cosine of 2 theta is equal to 1 minus 2 sine squared theta. We move the 1, so we have 2 sine squared of theta equals 1 minus the cosine squared, or cosine 2 theta, my bad. No, it is cosine squared. No, cosine 2 theta, I was right. Then we divide by 2, leaving us with the sine squared of theta being equal to 1 minus the cosine of 2 theta over 2. Now these are basically the same result. The only difference is that the cosine is plus and the sine is minus. That is really the only difference. So now we're going to use these identities in an application. We're going to do calculus for this one. So we'll do topic 4, applications of calculus. Alright, so we're going to solve the integral of cosine squared of theta d theta. We'll begin by using our identity we just found, 1 plus the cosine of 2 theta over 2 d theta. We'll move out the 1 and replace it with a 1/2 by, since it's still divided by 2, we're just separating it from the cosine of 2 theta. So instead we have 1/2 plus the cosine of 2 theta over 2 d theta. We'll split it into 2 separate integrals, so we'll have the integral of 1/2 d theta plus 1/2, we're going to get rid of the 2, we're going to do this in one step, 1/2 the integral of cosine 2 theta d theta. We'll move the 1/2 in front for this equation as well, so we'll have 1/2 the integral of d theta plus 1/2 the integral of cosine 2 theta d theta. Now here we'll do a u substitution. So u will be equal to 2 theta. So du over d theta is equal to 2 d theta. Du over 2 is equal to 2 d theta over 2, or 2 theta over 2. So then du over 2 is equal to theta. So now what we will do, because there's nothing left in this integral, it cancels itself out essentially. So we're basically just left with 1/2 of theta. 1/2 theta plus 1/2 the integral of cosine of u, sorry that's a d, cosine of u du over 2, like so. We can integrate this now. So we have 1/2 theta plus 1/4, moving the half from the du, sine of u. Which leaves us, if we plug u back in, with our final answer of 1/2 theta plus 1/4 sine of 2 theta. So, thank you very much for watching. Bye.